Hello everyone. Today we are going to continue on in proofs. And yesterday what we looked at was how to use the picture and the givens when you're really only given congruency, shared sides, or vertical angles. Today we're going to add to that a little bit. We're going to look at some other normal definitions and theorems that pop up when you try to prove congruency in triangles. And the ones that we're going to focus on are midpoint, bisector for both segments and angles, a perpendicular bisector, and then what happens with alternate interior and exterior angles. Now, when you're looking at these, it is kind of nice to just go through and draw yourself a picture. A lot of times when you have a midpoint, you're going to have something where you'll have a picture similar to that, where you know that that point's coming exactly in the middle. We're also going to have things like bisector. A bisector cuts something in half, so you might see a picture similar to this. Again, if we're talking about a segment bisector, that means that this and this will be congruent. But notice that this one by itself does not tell us anything about the angle here. We only know that these two pieces are equal. However, perpendicular bisector is going to give you two pieces of information, because not only does it tell you that it splits the segment in half, it also tells you that these will be 90-degree angles. So you actually end up getting an angle and a side when it tells you perpendicular bisector, which is really handy when we're trying to only find three pieces of information, an angle, a side, or another combination of those. Angle bisector is one that gets often overlooked. When you have an angle bisector, you have one angle with a ray that comes out of it. And this ray is going to split that single angle into two congruent angles. The last one that you should really watch out for is the alternate interior and exterior angles. And for this, what you really want to make sure that you have is parallel lines. If you are looking for this theorem, you have to know first that your lines are parallel, because that's the assumption that you're giving. If you have those parallel lines, then you can assume that those angles are congruent. So what you're going to be given usually is something like this, where you'll have those little angles marking them parallel. However, that must be written in your chart, so this one is going to take 2 steps when you do it. It's going to take a step to see that things are parallel, and then the second step will allow you to say then that the angles are congruent due to this alternate interior or alternate exterior angles theorem. So let's take a look then at the proofs that we can do. Now, there are a few things that you should do when you're going through a proof. First, don't panic. The first thing that you really need to do is just walk through the logic yourself. Make sure that it all makes sense to you before you try to do the whole chart where there's a lot of information going on at once. Second, if you're stuck, don't forget to check what is in your givens, because most of the time that students are stuck, it's because, well, we forgot one of the things that was given to us, and that's that missing piece of information. And the third thing to do is always check your theorem sheet for things that you can assume, like maybe you missed one of the vertical angles or the reflexive property, and also for definitions that you tend to overlook, like midpoint bisector, angle bisector. So again, don't be afraid to take some time to prove it to yourself. Second, look over your givens. And third, look for those theorems that we sometimes forget about, like vertical angles and reflexive property. So let's go with this proof. Now here, we know that C is the midpoint of BE. So when I'm looking at my picture, since C is the midpoint of BE, I know that BC has to be congruent to EC, and that is according to the definition of midpoint. So I'm going to just draw all over this picture to find my pieces of information. I also like to underline a piece of information from my givens once I've used it, so I know it's something that, hey, I took care of that, I didn't just ignore it. Then what I look for is my next given. I also know that C is the midpoint of AD. So I look over at AD, and I know that C is the midpoint. That means that AC is going to be congruent to DC. But now I'm done with all of my givens, and I want to prove that the triangles are congruent. But currently I only have side and side, so I need either the last side or an angle to be congruent. So here's where I check back at my theorem sheet, and I remember that if I have vertical angles in my picture, I can mark those as congruent as well. So I know that this angle here, this BCA, will be congruent to the angle over here, ECD, and that is according to the vertical angles. And according to my sheet, that's going to take 2 steps because I have to make sure to say that they're vertical angles before I use the vertical angles theorem. Well, at this point, I now have side, angle, side for my information. So I can start my proof because I know why these triangles are congruent. And when you're doing this proof, go ahead and give yourself side, angle, side as your guide through the proof. Now, unlike last time, our givens are going to be a little bit more involved because we're not just given a picture. This time, we are given this information. C is the midpoint of BE, the line segment, and AD, the line segment. And those are given pieces of information. So I've taken care of my givens on my chart. And don't forget this step. A lot of times we're in such a hurry to prove all our other things that we forget the foundation on which we stand. Also true to life. But let's worry about these sides. So I'm going to start by proving the side is congruent to another side. So here I knew that BC is congruent to EC. And I knew that because of the definition of midpoint. And since I've said that they are a midpoint, I know I can use definition of midpoint on my table. And so I've taken care of the first side. Now, I don't necessarily need to go to the second angle next. I could actually go to AC is congruent to DC and prove that, and that will be okay. So if you switch these steps around, it's not wrong. The only thing that's necessary is that you prove the side, angle, side before you say that the triangles are congruent. So I'm actually going to go in order here just because I like keeping it side, angle, side along the side here. So remember for the angle, since I'm going to be using the vertical angles theorem and I haven't said that they're vertical angles, I'm going to have to ensure that this takes those 2 steps because I can only use vertical angles theorem if I have already said the 2 angles are vertical angles. So let's say that they are vertical angles. Angle BCA and angle ECD are vertical angles. And that is according to the definition of vertical angles. And according to like our shortcuts, we're allowed to just say that one's a given if you would like. Now that we know that they are vertical angles, we can go ahead and use that vertical angles theorem to say that they are congruent to each other. And I've taken care of the angles. That leaves me with my final side. AC is congruent to DC. And that, of course, is according to the definition of midpoint, which I got out of my givens. So definition of midpoint, where I've already said it's a midpoint in my givens. Now that I've done these 3 steps, I can say that the overall triangles are congruent. So let's make sure that our corresponding points are right, and I can even just copy it right down from the top. I want to prove that ABC is congruent to triangle DEC. And that is according to the SAS triangle congruence theorem. Please be careful here that in each of the problems you have points corresponding correctly. A should correspond with D. That means that here in this segment, A corresponds with D. C should correspond with itself, so C and C, those should be in the correct spot. Same thing with the angles. A corresponds with D, B corresponds with B, C corresponds with C. So B and E get switched out, C stays the same, and A and D get switched out. Again, B and E switch out, C stays the same, A and D switch out. So just watch for that information. That is going to always be one of the points that you guys get, is keeping the corresponding points consistent in your triangles. Well, that is a completed proof. We've got 2 more to look at though, so let's take a look at those. All right, let's prove this to ourselves first. I know that AC is the angle bisector of DAB. So if I look at DAB, this angle right here, AC is going to bisect that. According to my theorem sheet, bisecting an angle means that it splits it into 2 equal angles. So that means, according to the definition of angle bisector, I can make those congruency marks. So now I have a side that was given to me in the picture. I have an angle. I just need one more piece of information. If I look at my picture here, I have used up my givens, but I do know that this has a shared side, right? AC is going to be congruent to itself according to the reflexive property. So that means right here I have side, angle, side. And that's enough to prove that triangles are congruent. So I'm going to go ahead and start my proof. And I'm going to start my proof with my givens. So AC is the angle bisector of angle DAB. Running out of some room there. And that was given to me. Next, what I want is I want to be able to say my sides are congruent. So let's go ahead and do my other given side. I know that AD is going to be congruent to AB, and that was given to me. It was in the markings that I did not make. When I move on to angles, well, I knew that my angles were congruent because of the definition of angle bisector. So angle BAC is congruent to angle DAC according to the definition of angle bisector, which I know I can write out because I've already mentioned it is an angle bisector. Which means I'm up to my final side, and that is the side AC. Now here, AC is going to be congruent to itself. And notice that in the triangle, the angle A corresponds with itself in both triangles, as does the angle C. So that means I'm going to keep it in the normal angle order. A corresponds to A, C corresponds to C. That is the reflexive property of congruence. And since I've now done SAS, I can go ahead and say the overall triangles are congruent according to the SAS triangle congruence theorem. Just watch your corresponding points. ABC is going to be congruent to ADC, where B and D are the only points that are swapping out. In our last one, I don't really have anything in the givens, but there is something extra in the picture that we haven't seen before, and that is that this line, PQ, is parallel to RS. And as soon as I look over my theorem sheet, I notice that, hey, parallel, well, that means I'm probably going to use alternate interior and exterior angles theorem, because that's the one with parallel in big letters. So if these 2 lines are parallel, that means that if we have a segment going through them, or a line going through them, RQ, that's a transversal coming through those parallel lines. And it forms alternate interior angles here at R and Q, and those must be congruent to each other because they are alternate interior angles. So as long as I know those lines are parallel, which I do, it was given to me, I am able to say that those 2 are congruent according to the alternate interior angles theorem. And I'm also going to be able to say that this side is congruent to itself. RQ is congruent to QR because of the reflexive property. So I have angle, side, angle. And I can put my proof together. That leads us to this proof. Please note that you have to say that the lines are parallel before you can use alternate interior angles theorem, so I had that as my first step for my givens. Also watch out that your corresponding points are correct between the 2 triangles. check that out and have a great day.